Lesson: Monitoring AI Model Performance. Monitoring AI model performance is a critical aspect of machine learning operations that ensures models remain reliable, effective, and aligned with their intended objectives. This process involves continuous evaluation and adjustment of models to adapt to changing data environments and user needs. Monitoring is not a one-time task, but an ongoing process that requires the integration of various tools, techniques, and best practices to maintain optimal performance. The first step in monitoring AI model performance is establishing baseline metrics that serve as reference points for evaluating model output. These metrics include accuracy, precision, recall, F1 score, and area under the ROC curve. They provide quantifiable measures of how well a model is performing in terms of its predictions. For example, precision and recall are particularly useful in scenarios where the cost of false positives or false negatives is high, such as fraud detection or medical diagnosis. By comparing current metrics against baseline values, practitioners can detect drifts or anomalies in model performance. Drift detection is another crucial aspect of performance monitoring. Data drift occurs when the statistical properties of the input data change over time, potentially leading to a decline in model performance. Concept drift, a subset of data drift, refers specifically to changes in the relationship between input data and target variables. Tools like Alibi Detect and River provide robust frameworks for detecting and addressing drift in machine learning models. Alibi Detect offers algorithms for both online and offline drift detection, enabling real-time monitoring of incoming data. Practitioners can implement these tools to trigger alerts when drift is detected, prompting further investigation and potential retraining of models. To effectively monitor AI model performance, it is essential to integrate automated monitoring systems into the MLOps pipeline. Tools such as Prometheus and Grafana are widely used for this purpose. Prometheus is an open-source monitoring and alerting toolkit that collects metrics from configured targets at specified intervals, stores them, and allows for querying and visualization. Grafana complements Prometheus by providing a powerful dashboard for visualizing data, making it easier to interpret performance metrics and trends. By setting up alerts for specific thresholds, these tools enable proactive management of AI models, ensuring that performance issues are addressed before they impact users. In addition to automated tools, human oversight remains a critical component of AI model monitoring. Domain expertise is invaluable in interpreting model outputs and identifying potential biases or errors that automated systems might overlook. Regularly scheduled reviews with cross-functional teams can provide insights into the practical implications of model performance and guide adjustments to improve outcomes. This collaborative approach ensures that models remain aligned with business objectives and ethical considerations. A practical example of effective AI model monitoring can be observed in the financial industry. Consider a large bank implementing a machine learning model for credit scoring. Initially, the model performs well, accurately predicting creditworthiness based on historical data. However, over time, economic conditions change, leading to shifts in consumer behavior and financial health. By employing drift detection tools and continuous monitoring, the bank can identify when the model's predictions begin to deviate from expected outcomes. Automated alerts trigger a review by financial analysts who determine whether the model needs retraining or adjustment to accommodate new patterns. This proactive monitoring approach helps maintain the reliability and fairness of credit scoring processes, ultimately protecting both the institution and its customers. Incorporating feedback loops is another essential strategy for monitoring AI model performance. Feedback loops enable models to learn from their mistakes by incorporating user feedback and real-world outcomes into the training process. This iterative approach supports continuous improvement and adaptation to new data environments. For instance, an e-commerce platform using a recommendation system can leverage user feedback to refine its algorithms over time, enhancing personalization and customer satisfaction. Implementing feedback loops requires careful management of data privacy and security, ensuring that user information is protected while still enabling meaningful insights. One of the significant challenges in AI model monitoring is the detection and mitigation of bias. Bias can arise from various sources, including training data, model algorithms, and deployment contexts. Unchecked bias can lead to unfair or discriminatory outcomes, undermining the credibility and effectiveness of AI systems. Tools like IBM's AI Fairness 360 and Microsoft's FairLearn provide frameworks for assessing and mitigating bias in machine learning models. These tools offer metrics for evaluating fairness and algorithms for reducing bias, empowering practitioners to create more equitable AI solutions. By integrating these tools into the monitoring process, organizations can proactively address bias and ensure that their models uphold ethical standards. Case studies further illustrate the importance of comprehensive AI model monitoring. A notable example is the use of AI in healthcare for predictive analytics and diagnosis. In one case, a hospital implemented a machine learning model to predict patient readmissions, aiming to improve patient care and reduce costs. However, the model initially performed poorly due to data drift caused by changes in patient demographics and treatment protocols. Through continuous monitoring and periodic retraining, the hospital was able to adapt the model to new conditions, resulting in improved prediction accuracy and better patient outcomes. This case demonstrates the critical role of monitoring in maintaining the effectiveness and reliability of AI applications in dynamic environments. In conclusion, monitoring AI model performance is an indispensable practice within the MLOps framework. By leveraging a combination of baseline metrics, drift detection tools, automated monitoring systems, and human oversight, practitioners can ensure that models remain effective and aligned with their intended objectives. Real-world examples and case studies highlight the practical applications of these strategies, emphasizing their importance in dynamic and high-stakes environments. As AI continues to evolve, monitoring will remain a vital component of responsible and effective AI deployment, safeguarding the interests of both organizations and users.